So hi guys, I'm Choi and I'm here to present about the Windows Userspace keylogger version 0.1. We are under the RITSEC mentorship program. We are working with Doc and Joe, and they've been really supportive, but I don't think they're both here right now. So moving on to the table of contents, I'm going to just briefly introduce my members and what we have done, and then we're going to go over some of the main functionalities that each of the group members went through, such as deployment, logging keystrokes, persistence, and regex, and then maybe some potential improvements that we could have done. So going on to the introduction, I guess I'll start first since I'm presenting right now. I'm Choi, second year CSEC, and I was responsible for deployment, and I really did not know what to do because you don't really learn about deploying keyloggers in school. So yeah, I had a hard time, but it was a really fun experience. And Stuart?
Yeah, hey, I'm Stuart. I'm a first year CS major, and I'm really interested in basically all low-level stuff. And then two group members that aren't here are Aaron and Andres.
Right.
Like reversing, binary exploitation, other related topics.
All right, so in terms of the project itself, it's a Windows Userspace keylogger. It really isn't that highly technical or anything. It was just a bunch of freshmen and sophomores trying to make something work. So for the language, we use C++ and we use Windows API. So for the deployment, I want to first say that it is highly not OPSEC friendly at all. I really did not know what I was doing, so chances are this is really not practical, not real world scenario at all. So going through deployment, I thought, well, malicious Windows Word macro is a thing. It's very classical, it's very old. However, I have to walk before I run. So I did my research and found out that PowerShell Empire actually has PowerShell payload that you can use for Word macro documents. So I tried it, but VirusTotal really did not like it. I tried obfuscating it. VirusTotal still did not like it. I tried this framework called Veil to bypass it. It still did not like it. So I was like, well, since I'm here to learn, I should probably just make it on my own manually. So I tried to do that. Programming in VBA was not fun, though. So the first thing that I noticed is having a PowerShell payload inside the macro document, it's an automatic red flag. It's like the antivirus does not like it at all. So what I did was I put the payload inside a text document and host that text document into my server. In this case, I used GitHub for testing, but you can host anywhere pretty much. And make the Word document to send out a HTTP GET request. Now, if you do that, the response that comes back will be just a plain PowerShell payload. Now, we can put that response into the wscript.shell function, and you can run it. In this case, now you don't have the PowerShell payload inside the macro document itself, so it was able to bypass a lot of antiviruses. So this is a simple topology. The attacker sends the malicious document first. The document sends out the HTTP GET request for the text file, which contains the PowerShell payload. It comes back with the HTTP response. The document uses that response as an argument to wscript shell, and then it will download the malicious file, keylogger in our case. Another thing that I found was having a suspicious string, such as wscript.shell, was not a good idea. So what I did was I put all of the quote-unquote suspicious strings into a one-liner using a delimiter in between and put all of that into the metadata of the document. So when I was actually running, when the macro is actually ran, I would get that using built document properties and whatever metadata that you used, chop them off using the exact same delimiter that I used, and then just use it as if I'm getting an array of strings, so to speak. So after all that, I got much better results. I was able to bypass Windows Defender, Kaspersky, Symantec, and Avast, some of the big antiviruses. One of the things that I found was that if you upload a good enough malicious file, there's this like automatic bot or script that runs that downloads your file and try to connect to your server as well. And I was just testing on my desktop and my laptop, and I actually got a reverse shell out of it because I was testing with Netcat. So yeah, that was pretty scary and fun at the same time. Deployment through the binary itself was pretty straightforward. It was using CPP, so I just created a new directory, created a replication of the binary itself, created a new process of that copied binary, and deleted the original binary because the original binary gets downloaded to C users public, which is not stealthy at all. So yeah, that's the route that I took. And for the copied flag, yeah, I learned the hard way because yeah, I pretty much kept creating the replication of the binary and creating new process as an infinite loop before, and it crashed my desktop multiple times. So yeah, that was the deployment.
Okay, now for the actual keystroke logging. To start, we use the Windows API. There's this function called get async key state that basically just tells you if a key is pressed and also if it's been pressed since the last time it was called. So initially, we didn't realize that and just thought every time it returned a non-zero value, the key was just recently pressed, and that caused us to just log a single press of A as like 100 A's. But later we realized that wasn't all it returned. Also, it was very annoying to handle like uppercase letters the way we had it implemented. We basically just wrote out like a lot of case statements where we just returned like the individual letter. So that was a little bit annoying, but it just took some time. And then for persistence, what we did was we added a registry key to this path, which that path is basically some place in the registry where Windows looks to run executables when users first log in. This is a really not stealthy place to put your persistence mechanism. Basically, that's one of the first places people will check for persistence. Then also, one thing that's really annoying is if file paths have spaces in them, Windows will like treat the second part as an argument. So you have to make sure to put quotes around all your file paths. And then Regex, what we did was we parsed like the keylogger output with regular expressions to parse things like phone numbers, social security numbers, emails, which were of the format of like text.domain.tld, and then names, which we detected by just looking for two capital words separated by a space in between. And then some improvements we could go into later is like completely deal with caps lock and all the shift stuff, and actually like finish that. And then also for persistence, we might want to save into the local machine rather than the current user. And what that would be is instead of just running every time this user logs in, it would run every time like the machine was turned on, I think.
All right, and for the deployment, something better than Word macro document because it's been out there for too long, and I don't think, and even the endpoint users are really educated enough not to click on that enable macro button anymore, so it was not realistic at all. And create more stealthy directory to put our replicated binary itself. And for the loots, we currently have it only in the local machine as a text file, which is not optimal at all. For the future, I guess we'll try to send the log file to the attacker's email. So for the demo screenshot, it's pretty much the deployment phase. The left is the victim, and the right is the attacker side. I just did the demo with the netcat, not the actual keylogger itself. If you press the enable macro on the left side, you'll see that it first tries to get the w.txt, which is the PowerShell payload, and then it uses that response to get the w.exe, which is netcat in this case, and you are successfully able to run netcat on that victim machine and get a reverse shell out of it. For the keylogging demo, it's just a video. So you write something. We're using the debug version. So we can see that all of the capital letters are being presented well. We do have left mouse click, and we are like keeping track of tabs or caps lock. So yeah, that is about it for our group. Thank you. We'll just yank it out.